Hello, this is my presentation on recovery and fatigue. Why is it that fatigue sets in? According to a source, fatigue involves the exhaustion of the muscle from prolonged exertion or overstimulation. The factors that occur in the body for this to happen are explored in more detail on the next slide. Before that, I will look at the symptoms of fatigue, which are shown here. They include tiredness, headaches, muscle weakness, slowed reflexes, impaired hand-eye coordination, and blurry vision, just to name a few. A sporting example whereby this would reduce the performance of an athlete would be in tennis. If a tennis player had poor hand-eye coordination with a contribution of a blurry eyesight, he will struggle to hit the ball, never mind in the right direction. To back this up, loss in power would reduce the speed that he can hit the ball. If you combine this with the other factor, then the tennis player will have a huge drop in performance. Moving on to the next slide, and this looks at the factors that affect fatigue. Here there is a list that shows all these factors. I will now go into more detail on these factors. There is decreased amount of oxygen levels in the body. This is the reason for there being an oxygen debt during exercise. The fact that there is an oxygen debt means that there is a temporary oxygen shortage in the body's tissues arising from exercise. Muscles need oxygen because of cellular respiration, where ATP is produced as oxygen breaks down the glucose. As there is not as much oxygen, this will reduce, meaning that the cellular respiration will reduce, meaning here will be less energy in the system. On the other hand, there is an increase in the amount of carbon dioxide. This is a product of aerobic respiration that occurs in the body. If there is too much carbon dioxide, it can be very harmful to the bloodstream, as enzymes in the blood speed up the reaction between carbon dioxide and water to form carbonic acid. When the carbonic acid breaks down, it breaks down into hydrogen ions and bicarbonate ions. The hydrogen ion is responsible for an increase in acidity of the blood. This brings me on to the accumulation of H plus ions, hydrogen ions, and increase in lactic levels in the muscles. This comes from lactic acid production when exercising. It immediately splits into lactate and H plus ions. The accumulation of H plus ions is the main reason for fatigue, as it impedes muscular contractions from happening. This occurs as the acidity of the muscle increases, lowering the pH. A lowered pH means that less and less glycogen is broken down, meaning that the rate and also the force of the muscular contractions decrease, resulting to fatigue in the body. Moving on, body temperature is well known to increase during fatigue. This is due to an increase in the amount of chemical reactions around the body. This causes fatigue as when the body experiences overheating. An extreme case of overheating is hypothermia. One of the results from this is dehydration of the body, which causes fatigue. This is because the body reduces its intensity to make sure that temperature and the amount of fluid is back to normal. This process is known as thermal regulation. Another main reason for fatigue is the depletion of the energy stores. The reason why all the energy stores deplete is because we have only a certain amount of them. Examples of this include ATP, which is we only have enough for 10 seconds use, which is the same for phosphocreatine. We have 15 to 20 grams of glucose stored in the body, while we have 350 grams of glycogen, which is enough for 2 hours. Each of the energy stores is used in different scenarios. The ATP store would be used for a weightlifter, while marathon runners will use most of their glycogen stores up. There is decrease in the macronutrient stores as well, carbohydrate, fats and protein molecules. These are used as secondary source energy after the other energy sources. If all these sources start to reduce, then the muscles struggle to find the energy to cope with the environment. This causes fatigue. I've already touched on fluid levels with dehydration. This is paired with electrolytes, which also decrease like fluid levels. Electrolytes are a number of chemicals that form together to get electrically charged particles in the body fluids. The electrical energy that it carries is necessary for muscle contractions. If there is little amounts of electrolytes left, then the muscles will start to cramp. Regarding the amount of calcium ions, these also decrease. This is because of its use in the sliding filament theory. This is the process of the muscles contracting. Calcium ions fit into the process as they bind onto the actin and myosin so that the muscles can then contract. If this iron is not available, then the process won't be able to be completed and the muscles then won't be able to contract. Finally, acetylcholine, acetylcholine, this becomes lower during exercise. It is an important chemical as it allows nerve impulses to be passed to the muscles, and when the presence of the chemical is not high, then aerobic glycolysis won't be able to happen. Both of these last two factors, acetylcholine and calcium ions, are part of the neuromuscular fatigue. This is when the muscle tissues are unable to receive signals from the central nervous system as quick as normal, or when the muscle won't be able to function properly. After doing exercise, the body tries to recover and go back to a pre-exercise state. This is known as the recovery period. As shown on the PowerPoint, excess post-oxygen consumption, otherwise known as EPOC, is the total amount of oxygen consumed after exercise in excess of pre-exercise levels. This state occurs in the body after a period of mainly anaerobic exercise. This means that the energy that is supplied for the contractions is from the anaerobic system. The product of the system is lactic acid. To counteract this, when the athlete stops exercising, the breathing rate will stay at an elevated rate. As breathing rate stays higher, this means that the extra oxygen is breathed in. This occurs so that the oxygen can break down the lactic acid into water and carbon dioxide, and also to replenish the ATP stores. As shown on the slide of the PowerPoint, certain things need to happen before a performer can return to their optimal level. ATP must be replaced, removal of all lactic acid, replenishment of myoglobin stores, restoration of muscle phosphagen stores, and finally replacing the glycogen that was lost. How long the recovery will take will depend on the type of exercise that they were doing, with it down to the length and intensity of the workout. Another factor that will affect recovery is that the fitter you are, the quicker you will recover from the exercise. On the EPOC graph on the slide shown, it shows the areas of oxygen deficit in the blue, and in the red and yellow it shows the oxygen debt. There are two components of oxygen debt: the alactacid debt, which is the fast component, and the lactacid debt, slow component. Firstly, the alactacid debt is the process that doesn't involve lactic acid. In this aerobic energy system is used with oxygen to replenish the PC and ATP stores for the next form of exercise in the body. It takes around 30 seconds to replenish half of the to replenish half of the recovery, and within 3 minutes 99% of ATP and CP can be used again. The lactacid oxygen debt take a lot longer to complete, as it lasts for hours depending on the exercise. In this oxygen is used to break down lactic acid into pyruvate. From there, pyruvate can be broken down into carbon dioxide and water. The lactic acid is removed / converted into glycogen and stored in muscle tissue or in the liver. After exercise, it is crucial to do a cool down, as it keeps the heart rate and breathing rate up. This helps keep blood flowing with adequate amounts of oxygen getting to where it needs to go. Failure to do a cool down will mean that lactic acid will remain in the muscles. The acidity in the muscles contributes to delayed onset muscle soreness, also known as DOMS. The athlete may feel DOMS for some time after the exercise. Next, I will look at 3 athletes which get fatigue in the body from their 3 types of exercise. All of these athletes that I have chosen are runners, but compete over very different distances, which cause a difference in how they get fatigue. The first athlete that I will look at is Usain Bolt, who is the fastest human to ever live. Despite winning many Olympic titles, he would still get a lot of fatigue even at his peak. Sprinters may be affected more often from fatigue because the majority of their muscle fibers are fast twitch muscle fibers. These fibers produce better bursts of speed, however they tire a lot quicker. In terms of the energy system that he predominantly uses, it is the ATP phosphocreatine system. This doesn't require oxygen. This is the quickest form of energy production. It is represented by the pink line on the graph shown on the slide. This system lasts for a maximum of 10 to 15 seconds, which is longer length of time for the 100 meters, but a shorter length of time for the 200 meters. This is why you see Bolt have a quicker 200 meter than the second 100 meter in the 200 meters. This is because the phosphocreatine is limited in its supply, leading to less energy in the muscles as they start to fatigue. After a race like this, it is key for Usain to get the right nutrition. After a race, he should take on board a lot of electrolytes. This is to make sure he replenishes his energy stores. That loss of energy after the loss of energy during a sprint. He must also make sure that his meal afterwards involves a lot of protein. The foods on the slide are examples of this food group. This is to repair his muscles as much it is to make them stronger. This is key in sprinting, as strength and power of the muscles is critical. The next athlete I will look at is Seb Coe, who used to also hold the world record for the men's 800 and 1500 meters. This is classed as a middle distance runner. The energy system that he would use is the glycolysis energy system. The graph on the slide shows glycolysis as a percentage of the energy being produced at different points. It is represented with a red line. This is another system which doesn't require oxygen. It can also be known as the lactate system. In this system, there is a breakdown of glucose. This creates enough ATP for around 3 minutes of intense activity. This length of time is in between the two distances that he did cover. As touched on previously in the presentation, the system can't cope forever as there is excess hydrogen being produced. This combines with pyruvate to form lactic acid. This is cleared from the bloodstream from the liver. This happens until the body can't keep up with the production of lactic acid, which is known as the lactate threshold. When there is lactic acid in the bloodstream, it increases the acidity and makes the muscle fatigue. Seb will get fatigue due to the high intensity he is running at, especially in the 1500 meters. Despite the fact that his lactate threshold would be extremely high, after a race or training, he should do a very good cool down as part of his recovery effort. This is to reduce the impact of DOMS through the removal of lactic acid. This is key at a world championship as there is more than one round of a certain event. A cool down will mean that he will be able to be in peak condition for the next day of competition. Sorry, I forgot to go on to the next slide. That's a shame. The final athlete that I will look at, as you can see, is Mo Farah, who is a long distance runner. He formerly ran in the 5,000 and 10,000 meters, but now is looking at marathon running. For all of these events, Mo will predominantly use the aerobic energy system. The diagram on the slide labels aerobic energy system and its energy production. In this system, the body uses fats and glucose to produce energy. The body first uses the glucose molecules. As for every glucose molecule, 38 ATP molecules are created when in the presence of oxygen. This is known as aerobic glycolysis. To help out after several minutes of exercise, the body uses fat stores, and for every molecule of fat, 128 ATP molecules are made when in the presence of oxygen. It is crucial for Mo to fill up on these stores as otherwise he may hit a wall, which is where his performance drops dramatically as his whole body would get fatigued. Especially in the marathon, in recovery he could use cryotherapy, which helps with muscle pain. In what takes 48 hours usually to get rid of, with cryotherapy, it takes around 3 minutes. This all happens inside a cryotherapy chamber. This is shown on the image on the right. This can help Mo in his training as he could train as hard every day of the week. Thank you for listening.